Alrighty, so hello everyone. This is my final project, my tugboat, the LS 1835. It is 18 meters long and has a 35 tons total uh, bollard pull. That's what that name means. So we've got just a few renders here, a few pictures, little inboard render there of the kitchen with the island and the bar and everything, and the settee, outboard profile render, and some perspective shots there. These turned out pretty nice, I think. Some more pictures here. Outboard profile that I really like. Another inboard render of the galley there. Yeah. So the design brief. Of course, it's an 18-meter harbor tug with an expected maximum bollard pull of 25 to 35 tons. That's what I expected from my parametric study. Accommodations for 4 people, 4,000 liters freshwater capacity, and 12,000 liters fuel capacity. Basic V-style fender arrangement, and it will also have firefighting capabilities. The use case. The goal here was to create a harbor tug with very good ship assist potential, so that it would be kind of a cover all bases kind of tug. It wouldn't just be limited to assisting ships and getting on and off the dock. It would be able to do more than that. Which was kind of the goal here. Of course, it would be able to double as a fireboat and assist fire departments in things like that. And yeah, some concept sketches here. As you can see, originally I was wanting to do that broken shear. I think it looks really good on these tugboats. Um, and how that is done is it's essentially a two-level deck. They've got stairs going up on either side of the deck, and the deck towards the bow is higher than the deck at the stern there. I eventually just ended up going with the straight shear for simplicity's sake. The research portion of this project was uh, very difficult and one of the most frustrating portions of it. People do not like to give information on their commercial boats. It's kind of kept down on lock, um, and so it was pretty difficult finding information for parametric study and stuff like that. Not many parameters that I could find for designing these boats. Thankfully, Matt Norian from Washburn and Downey, I got in contact with him, and he was a tremendous help with this project. And then also Robert Allen's tugboat design guide, that was a tremendous help online. And Damon Tugs, they also are a little bit more loose with the information they put out. They put out some good information about their boats. So, general characteristics of the vessel: two 1200 horsepower Bodwan 12M engines, two ZFZ drives, hybrid Z drives. Displacement is 167 metric tons, aka 167,000 kilograms. Um, Total maximum calculated bollard pull is 35 tons. And yeah, the hull shape. I decided to go with a double chine hull, which is a little bit less common nowadays for these tugboats. I do think that it looks really good. It's aesthetically pleasing, the double chine hull. But I think if I was doing this project over again, I most definitely would have used a single chine hull. It adds much more room, usable room for the engine room, and just makes the whole design of the boat much simpler. The mechanical. Mechanical is usually the main highlight of any tugboats. Um, and so in this engine room, we've got, of course, two 12M Boat 1 engines at 1200 horsepower connected to these hybrid Z drives. Um, And these hybrid Z drives, essentially all they are is it's a Z drive that can function as a regular Z drive with mechanical connections, but it also has an electric motor on there that it can use to idle around and stuff like that. So these generators are connected to the Z drives, charging these electric motors for whenever, say, I need to use the main engines to pump water for a fire. I would be able to use the electric motor on the Z drives to idle around. The construction, the LS 1835 hull is constructed of E32 AH32 steel. Um, that was like the middle range one on the ISO recommendations. And 900 mil frame spacing, 340 mil frame stringer spacing. Um, and yeah, this thing is a beast. It's not breaking. It's strong, you know. It's steel and it's very strong. 7.5 millimeter total bottom plating thickness. 4.5 was the calculated thickness from ISO, but since it is steel, you have to tack on some extra for corrosion and stuff like that. So here we've got a little explanation on what bollard pull is. The actual definition of bollard pull is the theoretical thrust achieved at zero speed of advance and full engine RPM. It's essentially just the pulling power of the vessel, and yeah, it's comparable to a horsepower rating for an engine. Um, Bollard pull can be easily calculated. It's not the most accurate calculation as to actual real world application, but it is accurate enough for these commercial designers to use and put on their designs. So it is pretty accurate. But bollard pull can also be measured in real life using a bollard cleat and a tow line and a one of these load cells they call them, and they essentially just measure the tension in the line, and they can actually find bollard pull using a line. Z drives are the primary propulsion method for most modern tugboats. They're very easy to operate and don't need much maintenance, and they offer amazing control of the vessel. They're an azimithing drive, an azimithing stern drive. Um, And azimithing, of course, just means 360 rotation, 360-degree control, which is amazing for tugboats because tugboats need to be highly maneuverable and kind of nimble, which seems odd because they're massive steel bathtubs floating in the water, but they do. They need to be able to maneuver around these boats and thrust in any way needed. So that's why these Z drives are used so commonly. Some things I would change about this project. I would switch to single chine hull. I would increase length just to add more room for the engine room. Um, in this project, I had to kind of chop away a good bit of my engine room to add for accommodations for four people. But that's all right. So yeah, I would increase length to around 20, 21 meters probably for that much larger engine room. Have a larger helm station, a little more comfortable helm station. I think I would do the broken shear just for aesthetic reasons. I think it looks great. Make the vessel more beamy. That is a big one that would really help with my engine room problems. And also, I would like to see about enclosing the winch inside the superstructure, which is a thing that Damon tugs are starting to do, where they have one center winch and they put it in the main superstructure there on the deck, and they've got like two windows that come out of the bow and the stern, and so the winch is enclosed and protected at all times. So we've got some references and inspiration here. This is a Robert Allen tug, 18 meters. Um, yeah, Robert Allen tugs, they do some amazing design. They've got some good information on their websites that really helped me out. Um, yeah, 18-meter tug here with the broken shear. Looks great. Um, on the bottom right there, those two pictures on the bottom right, that is a 16.3 meter Robert Allen tug with the straight shear. And then on the top right and the left side, that is a 19-meter Robert Allen tug. Well, yeah. And then this is the Damon 1810. This vessel was the main inspiration. As you can see, I completely ripped off the entire color scheme of this boat. Um, but for good reason. I think it looks great, and this is that boat with the enclosed winch. I don't, you can kind of see there on that bottom left render, that little black window looking thing. That's where the tow line comes out of that superstructure area there, which I think is really awesome. Um, but yeah, Damon and Robert Allen, they do some great work, and they were the main inspiration for this project. That is the end. Thank you very much.